Hello and welcome to this video that goes through exercise 7D of the AS Edexcel textbook. For proof questions, this is going through questions 11 to 15. So question 11, prove that x squared plus 8x plus 20 is greater than or equal to 4 for all values of x. So if we think about what this actually represents, essentially it's trying to say that if we have a graph, we can think of this as the y-axis here. So this is the y value, and it's saying that basically this curve is always above or equal to y equals 4. So it would imply that somewhere along, we don't exactly know where the turning point is at this stage, that the curve looks something like that along the line. So its minimum point occurs at y equals 4. So to prove that, we can find what the minimum point is. So to do that, we're going to complete the square and find what the minimum point is. So to complete the square, so we'll start with x squared plus 8x plus 20, and then we complete the square using the equation x plus b over 2 squared minus b over 2 squared plus c, where it's of the equation ax squared plus bx plus c. So here it becomes x plus 8 over 2 squared minus 8 over 2 squared plus 20, and that becomes x plus 4 squared minus 4 squared plus 20, and then from here it becomes x plus 4 squared minus 16 plus 20, so it's x plus 4 squared plus 4. So from here, from our one, we can say that the minimum point is equivalent to minus 4 and 4. And therefore from here we know that the minimum value, of x squared plus 8x plus 20 is equal to 4. And hence you have proven that for all values of x, x squared plus 8x plus 20 is greater than or equal to 4. Question 12, the equation kx squared plus 5kx plus 3 equals 0, where k is a constant and has no real roots. Prove that k satisfies the inequality 0 to k is less than 12 over 25. So in this case here, when it says it has no real roots, we're going to use the discriminant. So the discriminant states that b squared minus 4ac must be less than 0. So from our equation here, so remember it's ax squared plus bx plus c. So here a is equal to k, b is equal to 5k, and c is equal to 3. So therefore we're going to substitute that into our equation, so it's going to be bracket 5k squared minus 4 times k times 3 is less than 0. Then we expand our term, so it's 5 squared is 25, and k squared, and then minus 4 times 3 is 12, k is less than or equal to 0. So then from here we're going to pull out k, so it's going to be k because it's a common factor. So k, 25k minus 12 is less than 0. So therefore k is less than 0, or k is essentially, if we were to solve this as k, 25k, sorry, here we go. So k is equal to 0 or less than 0, and 25k minus 12 is less than 0. So therefore k is less than 12, 25k is less than 12, sorry, and then k is less than 12 over 25. So then from here we want to test k equals 0, because notice here that it has a less than or equal sign. So currently we want to test, so we want to say currently we have that k is less than 0, so we're going to plug in k equals 0 and solve this. So if we plug in k equals 0, we get 0 x squared plus 5 times 0 x plus 3 equals 0, which then this cancels, so we get 3 equals 0. So therefore we also know that this has no real roots because 3 cannot equal 0. One last check we want to do is, of course, is like, so here we haven't really shown that k, how we get the 0 is less than k part. So for that part we should really draw on the axis. So here we know that the root essentially, if this is k on our axis, we can say that the root here is when k equals 0 and k is 12 over 25. Wherever possible, if you have like a quadratic and you're trying to find an inequality, you should always draw it. In this case here, instead of x, we have k, so therefore we can draw this, and when we're trying to find the values whether it's below the axis, so here, that's where we can get our inequality of where k is less than, where 0 is less than or equal to k, which is less than 12 over 25. Again, 12 over 25 you can plug in to test this, but essentially it gives a proper value, so hence there is no equals to sign here, but the 0 part you have to show that y it's equal to, and that is because when you plug it in to your equation k equals 0, you cannot get a result. So yeah, that is your answer for question 12. Question 13, the equation px squared minus 5x minus 6 equals 0, where p is a constant, has two distinct real roots. Prove that p satisfies the inequality p is greater than minus 25 over 24. So to approach this one, again, two distinct real roots implies that we're going to use the equation, the discriminant b squared minus 4ac is over 0. Again, we're going to say that a is equal to p, b is equal to minus 5, and c is equal to minus 6. Substitute this into our equation, we're going to get minus 5 squared minus 4 times p times minus 6 is greater than 0. Minus 5 squared is 25, and then 4 times minus 6 is 24, minus 24, so it'll be minus 24p is greater than 0. So 25 plus 24p is greater than 0. From here we can rearrange, so we can say 24p is greater than minus 25, and then p is greater than minus 25 over 24. And therefore you've solved your inequality. You don't need to prove anything else from here. So that is your answer for question 13. Question 14, prove that A 3,1, B 1,2, and C 2,4 are the vertices of a right angled triangle. So you can, if you're really struggling to visualize this, you can draw out your situation. But again, that wastes valuable time in the exam, but it might be useful for you at this point. So 1, 2, 3, 1. So your first point here, A, is going to be at this point here. The next point, B, so 1 and 2, is going to be here. And C is going to be 2 and 4, 1, 2, 3, 4. So it's going to be here. So this is essentially your triangle. And you want to show that the vertices, they are a right angled triangle. Well, a right angled triangle here will have a angle. We can see if we draw our picture out, we can see that we have a 90-degree angle here, but you cannot use that as a proof that you've done it. So we need to work out something that has a 90-degree angle. So the way that you could find this is to prove that A and B here, or prove that two of the sides are going to be perpendicular to each other. So the method that we do to prove this is we find the gradients between the points. So the first gradient I'm going to find is between A and C. So A and C has a gradient. So again, to find the gradient, it's equal to change in y over change in x, which is y2 minus y1 over x2 minus x1. So here we're going to take C as the 2 and A as the 1. So it's going to be change in y, so 4 minus 1 divided by 2 minus 3. So AC is equal to 3 over minus 1, which is equal to minus 3. And then we can check AB. So AB is equal to, so again we'll take B as the second point, so it's going to be 2 minus 1 in y and 1 minus 3 in x. So this becomes 1 over minus 2, so it's minus a half. And the last one we have is BC. So BC, again we'll take C as the 2 and B as the 1, so it's going to be 4 minus 2 in y and 2 minus 1 in x. So 4 minus 2 divided by 2 minus 1, so it's going to be 2 over 1, which is equal to 2. So we can see here that the gradients are different, so they are not collinear essentially, so therefore we know that it must be a triangle. They're all going off at different angles. It's not a straight line. They're not going to join together. All 3 points can't join together in a straight line. So here what we can do is we can then say, well, we've got the gradient of AB and the gradient of BC. These two here, we can notice it just by looking at the gradient. You can also look at it in your drawing. But if we do AB times BC, we get -1/2 times 2, which is equal to -1. And the definition of a perpendicular line is M1 times N2 is equal to -1. So therefore, AB is perpendicular to BC. So therefore, the angle between them, BC and AB, is 90 degrees, and hence you have shown that it is a right angle triangle as they are perpendicular to each other. And there we go, we've shown here that our triangle, that our vertices, it must be a triangle. For the first steps first, to show that there's 3 distinct gradients between the points, to show that it must be a triangle, and then the second part is to show that AB is perpendicular to BC, which is therefore 90 degrees. The last question we have for this video is question 15. Prove that the quadrilateral A11, B24, C65 and D52 is a parallelogram. So to show this one, again we can draw it out to show what is happening. So you can visualize the shape. So we've got 1, 1, we have 2 and 4, 1, 2, 3, 4. So this is A, this is B. We've got C at 6, so 1, 2, 3, 4, 5, 6, and 5, 1, 2, 3, 4, 5, and D is 5, 2, 1, 2, 3, 4, 5. Okay, so this is C and this is D. So this is what's supposed to be a parallelogram. So there's 2 key things really for a parallelogram. Well, one key thing that we can find first is obviously with the name of the parallelogram, the sides are going to be parallel. So here we know, if we draw it out, we can see which 2 sides are going to be parallel. AB and CD are going to be parallel, and we also have BC and AD are going to be parallel. So to find whether they're parallel, we're going to find the gradient of the lines, and to show that they have the same direction. So AB, again, to find the gradient, M is equal to change in Y, change in X. So to find this one, it's going to be 4 minus 1 divided by 2 minus 1. So that's equal to 3 over 1, which is 3. And then we've got DC. So DC is equal to 2 minus 5 divided by 5 minus 6, which is equal to minus 3 over minus 1, which is 3. So therefore, AB and DC are parallel. Okay, and then we're going to test AD and BC. So AD is equal to 2 minus 1 divided by 5 minus 1, which is equal to 1 over 4. And then we're going to test BC. So BC is equal to 5 minus 4 divided by 6 minus 2. So 5 minus 4 is 1, 6 minus 2 is a quarter. So therefore AD and BC are parallel. So we've proven that the sides are parallel. However, that hasn't proven that it's a parallelogram. And the reason why is because if we look at another quadrilateral shape, for example, a square or a rectangle, they have an angle of 90 degrees between them. So here we need to test whether that there is a right angle essentially. So we need to check if there are any perpendicular lines. And we can see here that obviously 3 and 3, they are parallel to each other. But the other one we have is 3 times a quarter. And 3 times a quarter is 3 over 4. So therefore the gradients are not perpendicular, sorry. So therefore they cannot, they are not, or we could say the shape is not a rectangle, and or square. So therefore it is a parallelogram, which is the only other shape that we can describe what this is. So make sure for these questions when it says a parallelogram, you need to show that the angle can't be 90 degrees because, again, a rectangle and square, their sides are also parallel to each other, they're opposite sides. So again, just showing this is not enough. You'd only get half the marks. You need to show that also that this angle can't be 90 degrees. So yeah, just watch out for that. Again, once you've seen a question like this, hopefully, then if you get this in the exam, you'll be able to know that you need to do this extra step at the end to prove that it's a parallelogram and not a rectangle. Okay, that brings to the end of this video. If you have any questions, please let me know.